Hi everybody, welcome back to Math 245. Last time on Wednesday we talked about what it means for something to have a sample space. A sample space is simply all of the possible outcomes for a certain situation. And today we're going to talk a little bit more about sample spaces. So the sets of outcomes satisfying a certain set of criteria are called events. An event is just exactly what you think it is. It's just an event, right? A particular set of circumstances. If S is the sample space of an experiment, then an event is a subset of S. So these events are always a subset of a sample space. And this is pretty abstract, so we're going to do a couple of examples, and hopefully that will clear things up for you. So, the Battalion, Oregon State University newspaper, takes a survey of OSU students to determine where they are from, in-state, out-of-state, or international, and where in Corvallis they live, on campus, off campus, or out of town. So we first want to determine the sample space. This is all of the possible outcomes for this situation. So I have two things going on here. I have where they're from and where in Corvallis they live. So let's abbreviate these things. I'm going to say in-state, this is IS. Out of state, you know what? Sorry, that's a little bit too small, isn't it? So in-state is IS, out of state is OS, and international will be I. And then where in Corvallis they live, I'm going to say on campus, off campus, and out of town. Out of town. So for each of these scenarios, where they're from and where in Corvallis they live, I have three different possibilities. So to determine the sample space, I'm going to call it S. I have to see what possible combinations of these three scenarios I have. So my sample space, let's see, if a student is from in-state, then there are three possibilities for where in Corvallis they live. They either live on campus, they could live, or they could be from in-state and live off campus, or they could be from in-state and live out of town. Whoops. Out of town. So that's if they are from in-state. If they are from out of state, then they could be from out of state and live on campus. They could be from out of state and live off campus. They could be from out of state and live out of town. Finally, if a student is from another country, we have that they could be from an international place and live on campus. They could be from an international place and live off campus. And they could be from an international place and live out of town. So here, if we count these up, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 different different results from this particular survey. There are 9 different possibilities. So if I want to determine the event E1, out of state student, so that will be every situation that I have here where I am an out of state student. So that is OS. So I see that I could be an out of state student and live on campus, out of state student and live off campus, out of state student and live out of town. So E1, this is the event where they live out of state. So they could either live out of state and on campus, out of state and off campus, or out of state and live out of town. So this event is simply a subset of our sample space. These three elements here that we just wrote out are a subset of S. Okay, and then if we want to determine E2, which is neither in-state nor on campus, So I have to choose everything where the student is not from in-state and they don't live on campus. So this will again be a subset of my sample space S. So if I'm not in state, then I can either be out of state or international. So I could be out of state, but I can't be on campus. So I have out of state, off campus, and out of state, out of town. And then my other possibility for not in state is international, but I can't live on campus. So I'm international and I live off campus, or international, out of town. So here I have 4 different possibilities for this event, where I don't live in state, where I'm not from in state, and I don't live on campus. All right, let's do another example. Let's say you roll a standard dice 2 times and record the number facing up. Determine the event E3 where the sum of the 2 rolls is less than 5. So the number of possibilities I have here would be 36, because I have 6 possibilities for the first dice and 6 possibilities for the second dice. So I have 36 possible combinations of dice when I roll them both. But I'm not gonna write out all 36 possibilities. But I want to determine the subset of those 36 where the sum of the 2 rolls is less than 5. So I'm going to have several different possibilities here. I'm going to roll 2 dice. The order doesn't matter, but they are distinct from each other, right? So if I roll a 1 on the first dice and a 1 on the second dice, so this is first roll, this is second roll. Well, that's certainly less than 5. If I roll a 1 on the first and a 2 on the second, that is true. If I roll a 1 and a 3, that is less than 5. And that's it. I can't do a 1 and a 4 because 1 plus 4 is not less than 5. Okay, so what about if I roll a 2 on the first one? I could roll a 2 on the first time and a 1 on the second time. And I could roll a 2 on the first one and a 2 on the second one. And that's it. Because if I did 2 and then 3, that would be 5, and I need to be less than 5. And finally, I have one more possibility if I roll a 3 on the first one and a 1 on the second one. So notice that even though here I have a 1, 3, and here I have a 3, 1, those two are different from each other because in this one, I'm rolling a 1 first and then a 3. In this one, I'm rolling a 3 first and then a 1. So we include both of those since I'm rolling a dice twice. All right, so this is our E3, the event that the sum of the 2 rolls is less than 5. Again, if we wrote out this whole sample space, there would be 36 different combinations since each dice has 6 sides. So this is simply a subset of that sample space. All right, that's it for lesson 32. Go on to lesson 33.